So, good morning, class. Sorry, I cannot be in the class with you for the first day of our class due to my delayed flight. So, actually, I'm still traveling now if you watch the video now. And please follow the instructions on the course syllabus to register my math lab and through BBU. Please remember you do not need to pay for the access and you can directly through BBDU and register for the course. Okay, so that's very important. Yeah, so and you can start doing your homework. And for today, we will introduce the basic definitions of differential equations and what will be the solutions of differential equations and the corresponding initial value problem. Okay, so first, what means a differential equation? Differential equation means an equation containing the derivatives. Derivative, do you guys remember what means a derivative? Like dy over dx. We also learned a second derivative, dy squared over dx squared. And one or more unknown functions with respect to one or more independent variables. Are you guys with me? So what does this mean? If we respect to one or more independent variables, what does this mean? If y is a function of x, and one or more independent variable means y can be a function of what? X and t. Are you guys with me? So let's look at the examples. Yeah. So and for we have two types of differential equation. One is called what? ODE. ODE means a single independent variable. Yeah, so what means a single like dy over dx or second derivative? Yeah, and PDE means it is called what? A partial differential equation. Where does the partial come from? Do you remember? So if you guys learned calculus 3, like y equal to a function yxt, so instead of we use dy over dx, what should we use? We should use partial y, partial x, partial y, partial t, because y is a function more than one variable. And if we have a differential equations like this, we call it what? PDE, partial differential equations. Partial differential equations. Okay? Let's look at some examples. Yeah, so types of differential equations: dy over dx plus 5y equal to ex. You with me? So you only have what? One variable. So this is what? ODE or PDE? ODE. Yeah, and here is the second order, second derivative, first derivative, but you only have one variable x. Only one variable x. So this is what? ODE. And here x is with t, y is also with t. Means what? More than one variable, but it's the independent variable is only what? T. So x is only xt, y is also only yt. Independent variable is t, is a single t. So this is also called what? ODE. Yeah. So what will be called a PDE? Like for the equations like this, if u here must be a function of what? X and y, and for here u must be a function of what? X and what? T, because we have partial. And here u is a function of y, and so what do you mean? Here u is a function of what? Xy, and v is a function of xy. Yeah, why could I know that u is a function of xy? Because they use what? Partial u, partial v. If u is only a function of y, this means what? Du dy. You guys with me? So this is, and this kind of equations, in the next course, we call it what? PDE. PDE. For the moment, you just know what is going on. Okay? And the notation, yeah, so there are two notations. And for the notation that we learned in calculus 1, the Leibniz notation and the prime notation, just exactly the same, yeah. So dy dx we can sometimes write down y prime, the second derivative y double prime, third derivative is y triple prime. Okay, and y prime square, is this equal to y double prime? Remember, this is the biggest no, okay? So y prime square is still what? The first derivative. Y time y double prime is the second derivative. They are not equal. They are not equal, okay? So this is one of the things that you guys need to remember, okay? And the next one is the classification by order, yeah? So what will be the order of differential equations? The order is always the highest derivative in the equation. And for this example, yeah, what is the highest? It's 2. And do we care about here? Is cube, will this be considered to be the third power? No, because y prime square is still considered to be what? The first derivative. The cube does not give you what? Y triple. This means the cube does not make it the third derivative. So this is the order is still to be what? 2. It's still second order. Are you guys okay? So this is very important, yeah. So although it can be cube, but it will never give you, increase the or it will make it the second derivative or third derivative, okay? And so the next one is called a differential form. Yeah, so differential form, it can, we can, directly say this will be dy over dx will be what? Negative mxy nxy. With me, you move it and divide, yeah. So this is only a first order differential equation, yeah. So a first order differential equation, and if you can, what could you do? You can multiply dx on both sides and get rid of denominator, and it's called what? Differential form. Okay, differential form, yeah. Okay, so and if you have this one, y minus x, and it can be equivalently say this, for this one is, later on we will introduce linear to nonlinear. Actually, this is the definition for linear, okay? So, when we introduce the definition, okay? And what will be the general form? Could we isolate for dy over dx? What will we do? Dy over dx for x equal to what? X minus y. Are you with me? So what will we do? What will we get? Dy over dx, which will be x minus y over 4x. And it will be what? 1 over 4 minus 1 over 4x, what? Y. Are you with me? So, if you wanted to write it as, separately as a function, are you with me? You can do that. This, what will be the differential form? How could you find the differential form? This is what, this is to isolate dy over dx. Are you with me? What will be the differential form? Differential form is mxy plus dx plus nxy dy. What will be the differential form? We wanted to multiply dy dx. Yeah, so it will be y minus x dx plus what? 4x dy equal to 0. Did you see? So for here, you multiply dx through the equation. That will give you the differential form. And for this one, if you wanted to isolate, dy over dx to find the order, this is what you wanted to do. Are you guys clear? Yeah, so this is the, basic algebra, different form of differential equations, okay? Okay, and then, yeah, so this is the example to find a differential form, yeah? So how could we find the differential form? As we discussed, above, multiply dx on both sides, on both sides, yeah, and you will be able to get this. This will be a differential form. Okay. Okay, and the classification by order. So what we mean, what is the general form of the nth order differential equations in one dependent variable? So we write down in the nth order will be fx, y prime, yn equal to 0. Okay, and so what were, so could you give me an example? Could you give me a second order differential equation? What does this mean? Y double prime minus what? 2y prime plus what? 5y minus what? 3x equal to 0. This will be what? The general form. This is what it means, yeah? So you have, double derivative, first derivative y and x term. Are you guys with me? So this means, the general form. Okay? The next form that we wanted to talk about is called what? The normal form. Yeah, so what is the difference between the general form and normal form? So the general form is everything put together, one side to be a bunch of equations, the right side will be 0. What will be the normal form? The normal form, we wanted to what? Isolate the highest order on one side, put everything on the other side. Are you with me? So this is the general form here, yeah? So what will be the normal form for just the top equation? What is the order of the above equation? It must be what? 2. It's a second derivative, yeah? So it must be 2. And then what do we want? We wanted to isolate y double prime on the one side and move all the other term on the other side. Means 2y prime minus 5y plus 3x. Are you with me? So y double prime you also know, yeah? So this is what, if you want to write it as this one, is the second derivative, 2 first derivative, and minus 5y plus 3x. You with me? So, either of this way, this way. And this is called what? The normal form. This is called the normal form. This is called what? The general form. Yeah? So pretty straightforward definitions. Guys, okay? And so, this is the example we already done, yeah? So, we already did it, yeah? So dy over dx equal to this. And y double prime, this is also a similar example that we did above, yeah? We did above, okay? You guys okay? Okay, yeah, and so the next one is, the next definition that we wanted to talk about here is linear and non-linear, yeah? So linear means, okay, so when we wanted to talk about the linear of differential equations, what do we care? We only care about the coefficient of the what? Y double, y prime, and y to the nth derivative. Are you with me? So what could we have? We can have any functions of what? X. Any function of x means it can be a function of, you can include x or what? Constant. We cannot include anything else. Okay, so we can only have y. But if we have 1 over y, is this okay? No, because this is what? Y to the negative 1. We do not have this term. Are you guys with me? Could we have y squared term? Biggest no, because we can only have y, something x with multiply y, or y prime, or something. Are you with me? Could we have 1 over 4x y prime? This is perfect, yeah? So because this is y prime, and this is the function of x. And for the function x, we can have, whatever it look like. Are you with me? So, but for y, you cannot have, 1 over, or, you can only have y prime. And for x, you can do whatever. Oh, another one. Could we have cosine y? Biggest no too, yeah? So because cosine y, cosine of y is not only y itself. Are you with me? So it's a trigonometric function. So y and could we have square root of y? As we already talked about. Yeah, so this is the biggest no either. Yeah, so this is what linear and nonlinear. Let's look at more examples. Yeah, so what means nonlinear? It's not linear, then it will be nonlinear. Okay, so all the function that I put cross sign, it's called what? Nonlinear. So let's look at the examples. And for the second example, this is perfect. Yeah, 1, -2, 1, it's a perfect linear. X cube, function of x, a function of x. -5 is also a function of x. Constant can be considered to be a function of x. Yeah? Are you with me? Constant is always included. Are you with me? So -5 this is okay. And e to the x is also a function of x. But for the first one, what will be this? Y minus x dx plus 4x dy equal to 0. What do we do? We can write down dy over dx equal to what? Do you guys remember? I did it. Yeah, I did this example. What did I get? 1 over 4x minus y is what? 1 over 4 minus 1 over 4x times y. Is this linear? Let's check on the definition. 1 over 4 is okay. This is a number. How about -1 over 4x? Is this okay? This is also a function of x, yeah? a0x is a function of x, so this is perfect. Yes, we already emphasized 1 over 4x y, 1 over 4x is only a function x. For x, we do not care. We only care for the power of the y. We only care about the power of the y. Okay? So now let's look at some example that is nonlinear. So what will make it nonlinear for the first one? Because you have an extra y for the coefficient y prime. How about the second one? Remember, trigonometric functions that give us trouble. The third one, what happened here? Y squared. Yeah, so this is not y anymore. Okay, so and then the next one, yeah, so this one is, what is the order of this thing? Do you guys remember? This is not y double prime, not biggest, no. Are you with me? So this is still first order. And so when we learned in Coordinate algebra, we can solve the first order. Y prime equal to this, use the what is the formula that you are using? It's called a quadratic formula, yeah? So we wanted to ask you, if we have y prime equal to this, is this linear? So we have -x is okay. But what do you have here? What is the power of y? It's y to the what? A half. Is the half okay? No, we can only have what? Y to the 1. Nothing else. Yeah, so this is what? This is why this is what? Nonlinear first order. Yeah, so just be careful. Y prime square is not what? Y double prime. And the square root of y, that will make it what? Nonlinear. Okay, and the solutions of a differential equation. What means the solution of equation? Solution of equation means what? You substitute and you make sure the equation left equal to right. Yeah, that is the same thing for differential equations. Differential equation is still equation. Yeah, so what means the solution? You substitute and make sure the left equal to right. Okay, so how could we verify it is a solution? dy over dx equal to x to 1 to the half, y equal to 1 over 16x to the fourth. How could we verify? Substitute, yeah? So left equal to dy over dx. Are you with me? So the derivative of 16 x to the 4 means what? 1 over 16 times 4x cubed. 1/4 x cubed. You with me? So what will be the right side? Equal to x, y a half. A half means square root, yeah? X square root of 1 over 16x to the fourth is x. 1 over 16 is 1 over 4. x4 is x squared. So 1/4 x cubed. Are you with me? What did you get? Left and right are exactly the same. So what verified? Are you with me? So this is what verified. These are the details. Okay? You just substitute and verify the left equal to the right. Yeah. So the next thing that we wanted to talk about is explicit and implicit solutions. So what means explicit solution? Explicit solution means, okay, so means your y will be equal to a function of x. On the right side, you only have what independent variable, no y anymore. Are you with me? So like for example, this one. So this is a explicit solution. Why? Because look at on the right side, you only have x and what constant. Do you have y? No. Okay, so this is what explicit solution. And how could we verify this is what this is a solution? So because phi x, we wanted this to be y, yeah? So y prime, which will be what? Negative c e to the negative x plus 2d e to the 2x. Remember, yeah? E to the 2x. Y double prime is c e to the negative x plus 4d e to the 2x. Are you with me? Then you will what? Substitute in, yeah, I c e to the negative x plus 4e to the 2x minus plus c e to the negative x minus 2d e to the 2x minus 2c e to the negative x and minus 2d. Yeah. What did you notice? What did you notice? c minus 2c is always equal to 0. So what happened? What did you notice? It's always works, yeah? And so I want to ask you a tricky question. How many solutions does this differential equation have? Somebody will tell me, this is what infinitely many. Why is it called infinitely many? Because what happened? No matter what c and d you choose, any real numbers, this solution, this always satisfies this differential equation. This means it's always a solution. Because when we substitute, do we care what c and d? No, it's always what cancelled. It's always cancelled. Okay, so this also tells you for the differential equations how many solutions do typically have. Infinitely many. Okay, and so we will talk about it later, and we will call it what a family of solutions. Okay, and so what about the implicit solution? When you have y squared minus x cubed plus 8 equal to 0, implicit defines a solution. What means implicit defines? Y is not clearly as a function of x. Are you with me? You have already inserted here. Are you guys with me? Yeah, so for here, you can still solve like y equal to what? Plus or minus x cubed minus 8. Are you with me? You can still solve. But if I give you a function like sine y plus e to the y plus cosine y minus 2x equal to 0, could you find y easily? Not really, yeah? This is too hard. Are you guys with me? This is too hard. Yeah, so this is called what? Implicit solution. Yeah, implicit solution. How could we solve implicit solution? Does this remind you something? what should we do? Two words. What should we do? It's called what? Implicit what? Differentiation that we learned before, yeah? So this is the implicit differentiation. How could we do implicit differentiation? We have what? Y squared minus what? X cubed plus 8 equal to 0. We wanted the derivative of dx. Y squared is what? 2y. Do not forget, this is y, then we have dy over dx. And x cubed is what? 3x squared. Just do the derivative, yeah? And then x is dx over dx. 8 is 0, yeah? Derivative constant is 0. Derivative constant is 0. So what do you have? Dx is what? 1. Are you with me? So this is 2y dy over dx minus 3x squared equals 0. So then this equals 3x squared. So what did you see? This is this. Are you with me? So how could you verify an implicit solution to be the implicit equation to be a solution of a differential equation? What will you do? You just what need to do the implicit differentiation on both sides. That's easy, yeah? Okay, and so this is the implicit solution definition. Gxy is two said to be, I should have these slides in front of the other one, yeah? So, if you have all the xy's together, is not y equal to something, but y is hidden in the equation. Yeah, so then it's called what? Implicit solution. And typically, how could you verify this is a solution? We wanted to use what? Implicit what? Differentiation. Is what? Implicit differentiation to do it. Yeah, so what will you do? We wanted the derivative with respect to what? X. So this is 2x dx plus what? 2y dy dx equal to 0. Are you with me? So this is what we have here directly. Okay, and so there is another method, yeah? So because if it's pretty easy, yeah? So when you have x squared plus y squared equal to 25, you can also solve for y. If it's easy to solve, you can also solve for y. What could you do? Then, use the method when we have example 1, and then what? Substitute and verify. Okay, we can do that too. Okay, so this is how you verify the implicit solution. And we also wanted to learn the definition of families of solutions. Do you know what means family of solutions? And we already talked about, yeah? So when we give the example, do you remember the example that, we talk about, here? And C and D can choose what? Different constants, yeah? So it's more than one solution. So we can call this what? A family of what? Solutions. So what will be a particular solution? So if we have C, what do we have there? I wanted it to be C e to the negative x plus what? D e to the 2x. This is y. Are you with me? Okay. So what will be called a particular solution? A particular solution means we do not want it what? Parameters. What are the parameters? C and D. Are you with me? You can choose what? C equal to 1, D equal to 2. Choose whatever, yeah? So e to the negative x, e to the 2e to 2x, this will be called what? Particular solution. This is called what? Family of solutions. Are you with me? Is this called one parameter family of solutions? No, because here you only have one variable. This is called one family. And if you have this, how many variables do we have? C and D. So what do we call it? Two parameter family of solutions here. You guys okay? Okay. This is this one, okay? So now let's look at this one, yeah? So if we have y equal to cx minus x cosine x, and you can verify this is a solution, you can verify it, after class. I will not do it here anymore, okay? And is this one parameter family? Why? What are the free variable? C. Are you with me? So C is a free variable, yeah? C is a free variable. Do we have a D anymore anywhere? No, yeah, so only X, yeah? X is it's not a parameter, it's variable. Are you with me? C is a parameter. You with me? And how could we make a particular solution? The particular solution means what? You wanted a specific value. Specific C will give you what? A particular solution. This means you can choose what? C equal to 1, which will be what? X minus what? X cosine X. Or you can choose C equal to 0, y equal to negative X, okay, X cosine X. Are you guys with me? So that will be called a particular solutions. Yeah, so if you draw the picture, you can draw different pictures with different value. Are you with me? So what happens, if we find the C, and we can determine which particular solution that we want. Okay, how could we find the C that will involve with what? The next thing that we want to learn is called initial values. Okay, and so this is another example, like this is this second order equation. We can, choose a C1, different C1 and different C2. Are you with me? I think this is C1 and C2. You with me? So you can choose the different C1 and C2 values, and you will be able to graph the different curve. Yeah, so you can use your graphing calculator to play with it. Are you guys with me? And so I strongly recommend you guys substitute and verify this is a solution. Substitute and verify this is a solution. Okay. And so the next definition is called a system of ordinary differential equations. A system of equations means two or more equations, yeah? So, if we have dx over dt equal to this, dy over dt equal to this, then this is called a system of differential equations. And if we want to solve it, then, continue to solve it. Or if you wanted to find a solution. If you wanted to find a solution here, what do we need to do? Means what? It has to satisfy each equation. Are you with me? If only satisfy the first equation or the second equation, this will not be considered to be a solution. Yeah, it's the same as what in coordinate algebra when we have, like linear system equation 2 or 3 or even more. Are you with me? If you want to claim this is a solution, it has to satisfy every equation. Okay, so that is the only thing. The next one is what? The initial value problem. What will the initial value problem do? Is actually this will be what? To tell you which particular solution that you want. How could we think about this? Yeah. So like, if your mom wanted, if you have 5 siblings and your mom can only afford taking one child to the dinner for tonight, which one she should choose? Are you guys with me? Yeah, so your mom will definitely put some, conditions. This one has already completed the homework. This one has already volunteered to clean the room. And this one has already volunteered to clean the bathroom. Are you with me? And we wanted to put all these conditions to what? To select only one solution. Because we have all five are the case, are the potential ones. They are a family of potential solutions. Are you with me? And if you wanted one, then you have to put some conditions. This is called the selection criteria. Yeah, so what will be the selection criteria in mathematics? That will be the initial values. Okay, so what will initial values do? Okay, so what will be the initial conditions or initial values do? So we can look at a picture. Yeah, so if you have a differential equation, if you have yx0 equal to y0, so yx0, y0, this means it has to go through this point. If these are all what solutions, are you with me? If it has to go through this point, what should we do? This will be the solution that we want. Are you with me? Because all the other ones will not go through the solution. Go through this point. Are you guys with me? But sometimes like for the second derivative, are you guys with me? For the first derivative, you only need one condition. Second derivative, you have two conditions. Nth derivative, you have n condition. N conditions because different equations. Yeah, and so sometimes only one condition cannot select. Yeah. So if we wanted to see, like your mom wanted to say, who completed the homework? Maybe 2 kids has already done. Raise their hands. Are you guys with me? Then, you cannot take 2 because you cannot afford it. Then we want who cleaned the room? Maybe only 1 left. Yeah. So this is like, the second differential equation is what? We have what? 2 conditions. And for this, if they satisfy both of the conditions, yeah, most likely only one solution. Okay. And so if you have, like the nth differential equations, yeah, so the nth order differential equations, you should have what, if you wanted one solution, how many initial conditions should we have? N initial conditions. Okay, this is typically true. Okay, so we will later on when we will go through these things with more specific examples. For the moment, you only need to know these things. Okay, and for example, like y prime equal to y. Yeah, y prime equal to y. So what does this mean? The derivative equality to self. What equation? What function is the derivative equal to self? Everybody knows equal to e to the x. The derivative equal to itself. Yeah. Is e to the x the only solution? How about 2e to the x? How about 3 times e to the x? It's still the same. Are you guys with me? So this is the general solution is what? Y equal to ce to the x. Oh, you do not need to know this. I only wanted to give you an easy example. Are you guys with me? We will learn how to solve this later on. Yeah, so y equal to ce to the x is a 1 parameter family of solutions. Are you with me? So sometimes y ce to the x. Okay, so what will be the initial conditions do? So if we have an initial condition y0 equal to 3, are you with me? If y0 equal to 3, this means when x equal to 0, y has to be equal to 3. Let's plug into the equation. y0 has to be ce to the 0 has to be equal to 3. Are you with me? So then what could you say? C has to be equal to 3 because e to 0 is 1, no? Once you have c equal to 3, what do you have? Y equal to 3e to the x. What do we call this? Do you guys remember? Particular solution. Are you guys with me? So the initial conditions or initial values will give you a particular solution of a differential equations. Okay, that's very important because when your mom wanted to take somebody, she only wants one. So she only wants one. Okay, so this is kind of the things that you guys can go over. Yeah, so you can look at some more examples. Yeah, so this is a very interesting example. It's a 2 parameter family of solutions. Yeah, so these examples are pretty useful later on. So later on, we will give you x, the second derivative x double prime plus 16x equal to 0. We'll ask you, how could we solve this? You have to find this. Okay, for here, you only need to what? Verify the solutions. Later on, we have to learn how to solve it. Okay, and you can look at the conditions. It's the same thing as before. So because these are called what? A general solution. How could you find a particular solution? This means what? Plug into x equal to x 2 pi. X pi over 2 means c1 cosine pi over 2 plus c2 sine 4 times pi over 2 equal to what? Negative 2. And then what will be the x prime pi over 2? X prime, do you guys remember what is x prime? Is negative 4 c1 sine of 4t. Are you with me? Plus what? 4 c2 cosine of 4t. Are you guys with me? Yeah, so first thing you should find what? X prime of t, and then what? Substitute, and then get it. Okay, get it. Okay, then you can find your C1 and C2. You will be able to find, once you find C1, C2, what you have already done, you find a particular solution. You guys with me? Okay, and the next one is existent uniqueness. Existence means what? Do we have solutions? Uniqueness means, is the solution unique? Yeah, so that's very important. Yeah, so if the solution unique, that's perfect. Then we only need to play with this solution, and it's so easy. Yeah, think about it. If your mom only has one child, how happy could she be? Yeah, okay, and so and then you can look at the thing. And this example, the next example is a very tricky example, and we will use it a lot. Are you guys with me? Later on, okay? For the moment, you only need to know that 1 over 16x to the fourth, we already proved this is a solution, and y equal to 0 is also a solution. Later on, if I give you this, yeah, later on, you also need to remember, do not forget the solution. Do not forget y equal to 0 is a solution. Because y equal to 0, dy over dx equal to 0. X times 0 is 0. Are you with me? So a lot of times, a lot of students will forget y equal to 0 is solution. So later on, remember it. Okay, I will remind you when it's time. Okay. And what this theorem, you only need to know there is existent a unique solution, theorem. Okay. So what are the conditions? Means if f, x, y, and partial f, partial y are all continuous, we will say that it's always what? A unique solution. Okay, so you do not need to understand this too much. You just remember this is a fact. That's all. Okay, that's all. Okay, so that is for today, and